So this video is going to be the first in a couple of videos that focus on making exponential equations from tables. So first thing is we've got to know, well, what does an exponential equation look like? So right here is what our exponential equation is. Y equals a times b to the x power. So x is your exponent, a is your y-intercept. It is where x equals 0. So when you look in your table and you see in your x column a 0, the y value that goes with it is the y-intercept, and that's the number that would go in place of a. B is called your multiplier or your factor, okay? And that word multiplier, multiplication, is key when you're making an equation. When you're looking at your y values and you're trying to figure out what you're multiplying by or dividing by each time, it's okay to think of division, but when you write the equation always has to be written based on multiplication. So what I mean by that is, if you notice that the y values are being divided by 2, as multiplication, that means you're multiplying by 1/2. Just like if you were to say divide by 4 on the y values, that means that you would be multiplying by 1/4. That's what I mean when I say written in terms of multiplication, all right? So a couple of key points to remember when you are trying to make the equation. Some of this we kind of already talked about. One, your y-intercept occurs where x equals 0. We just mentioned that. If your multiplier, or let me back up. If as your x values are getting bigger, the y values are getting bigger, then the table is showing exponential growth. So your multiplier, the number that will have x as the exponent, has to be greater than 1. If when you look at your table, the x values, they're getting bigger and the y values are getting smaller, then that table is showing exponential decay. And that means that your multiplier has to be between 0 and 1. You can think of it as being less than 1 if that helps, but less than 1, you've got numbers that are less than 1 that are negative. Your factor or your multiplier is never going to be negative. That's why we normally want to say between 0 and 1. But if it helps, you can think of it as being less than 1, okay? And then this last little bullet point here, always notice what happens to y as x gets bigger. We just kind of talked about that, but it is how you figure out, is the table showing growth or is it showing decay, all right? So let's do a couple of really basic ones first. So on this first one, as the x values are getting bigger, look at what the y values are doing. They are also getting bigger. So this table is showing exponential growth, okay? Now, to make the equation, we've got to have two things. We've got to have a and we've got to have b. A is your y-intercept. A y-intercept occurs where x is 0. Well, here is a 0. The y value that goes with that is 4. So your a value will be 4. And actually, let me clear out that. So a will equal 4. And then we've got to figure out b. So b is your multiplier. So what are you multiplying by each time to go from one y value to the next, okay? Now, in this one, it's probably fairly easy to see. 1 times 2 gives you 2. 2 times 2 gives you 4. 4 times 2 gives you 8. And 8 times 2 gives you 16. So here you are multiplying by 2. So your b value is going to be 2. Your equation then, guys, would look like y equals 4 times 2 to the x power. And that's it. Now, let's say that you weren't sure how the numbers were multiplying. What number were you multiplying by to go from one term to the next? As long as you can tell that the y values are getting bigger, okay, all you need to then do is say, well, 16 divided by 8 gives me 2. 8 divided by 4 gives me 2. 4 divided by 2 gives me 2. 2 divided by 1 gives me 2. That's how you could figure out the number that you're changing by each time, okay? And then you just have to say, well, the numbers are getting bigger. the y values are getting bigger. That's what I meant there, guys. Y values are getting bigger. So that number in parentheses has to be bigger than 1, okay? Also, and I didn't mention this earlier, make note of what the x values are doing too, okay? A lot of the time, your x values are going to be changing by 1. So -2 to -1, -1 to 0, adding 1 each time. There are certain instances where that is not the case, and you'll handle the coming up with the equation a little bit differently in those scenarios, okay? But just make note of that too. So let's look at another basic one. So on this one, our x values are going up by 1, just like in the last one, but the y values are going down. So this equation, or this table, is showing exponential decay. The equation, you're still going to use the same basic format, but that b value has to be between 0 and 1, all right? Our y-intercept, we've got that. Where x is 0, the y value is 25. So a will equal 25. Now, when you go to figure out the y, or figure out the factor or your multiplier here, guys, when you look, you notice that the y values are getting smaller, okay? And at first, you can think of it as division if it helps, all right? 625, we don't really know what 625 divided by what gives us 125, okay? But find some numbers that you do recognize and you know that you can figure out quickly. For example, 25 divided by 5, that gives us 5. 5 divided by 1, that gives us 5. So then, if you see that you're dividing by the same thing there, try that between your other y values. 125 divided by 5 gives us 25. 625 divided by 5 gives us 125. So we're dividing by 5 each time there to go from one y value to the next. But remember what I said earlier. When you make your equation, if we were to write it with a 5 in for b, that 5 is greater than 1, which means that the equation is showing exponential growth. But we already talked about a moment ago, this table shows exponential decay because as those x values are getting bigger, the y values are getting smaller. That's why when you make your equation, okay, you have to make it in terms of multiplication. So dividing by 5 is the same thing as multiplying by 1/5. So this would not be the equation. Instead, it would be y equals 25 times 1 over 5 raised to the x power, okay? So I'm going to stop this video here, and then we'll do another video that looks at a couple of examples that are a little more, just have a little bit more stuff to figure out.